Okay, let's unpack this. Imagine stepping through an opening, right? Not into a room, but into the very earth itself.
Hmm.
And the first thing that hits you isn't like total darkness or even biting cold, but something, well, unexpected.
Okay.
A smell. A really distinct, peculiar smell. It's earthy, sure, but also kind of cheesy. Maybe sweaty socks.
Sweaty socks, really?
Yeah, and even a hint of like horse manure. It's specific.
Wow. Okay, so you're painting quite a picture there.
You're standing inside this tunnel, you see, carved deep into what feels like incredibly hard ground. But it's not normal rock.
Right. It's permafrost.
Exactly. Ground that's been frozen for years, decades, sometimes millennia, and you've just walked into this world like literally frozen in time.
A hidden archive.
Yeah, an archive of Earth's past that is now, well, it's increasingly showing signs of melting.
That sensory detail, that smell you mentioned, it really does pull you into this unique environment. And it's, I think, the perfect way to introduce our topic today.
Permafrost.
Permafrost. You know, what it is, why it's fascinated everyone from, like, engineers to scientists for ages, the incredible, almost baffling challenges of trying to build anything within it.
Right.
And crucially, the profound and rapidly escalating impacts as it starts to thaw, especially, for the communities who actually call these cold regions home.
Exactly. And for this deep dive, we've really gone through a pile of sources, everything from, super technical reports detailing the nuts and bolts of experimental tunneling machines to these deeply personal accounts you find in research, talking with Northern Indigenous communities, people who are right there on the front lines, seeing it, living with these changes every single day.
Yeah, their perspective is absolutely vital. So our mission today really is to guide you through this multifaceted world. We'll explore what permafrost actually is fundamentally. We'll delve into a specific, really fascinating example, the Alaska Experimental Permafrost Tunnel.
Right, the Fox Tunnel.
The Fox Tunnel, yeah. We'll look at the unique engineering hurdles involved when you start disturbing this frozen ground. We'll witness the physical signs of its instability.
Which are becoming more obvious.
Definitely. And, most importantly, connect all of this back to the very real human experience, the transformations happening across these huge landscapes.
So join us as we try to unpack the knowledge that's embedded in all these sources. Let's explore this part of our planet that's somehow both ancient and changing incredibly fast.
Okay, let's dive in.
Let's start right at the beginning. The absolute basics. What is permafrost?
Okay, so the sources describe it pretty simply. It's ground material, could be, unconsolidated soil, stuff like alluvium, moraine, sand, silt, gravel.
Right, the loose stuff.
Exactly. But it's all cemented together by ice. And when it's frozen solid like that, it acts essentially like rock. It's incredibly hard.
And the key thing, the defining bit, is that the ice holding it all together stays solid, right? Like close to 0 degrees Celsius or below for at least 2 consecutive years.
That's the technical definition, yeah. 2 years minimum. And for a long time, this really unique material, it sparked interest beyond just, say, geology or basic construction. Some of the older technical reports we looked at, they hint at potential military advantages even.
Military? How so?
Well, because it's frozen solid, permafrost has this surprising ability to absorb energy from high-velocity shocks. Think explosions.
Okay.
It doesn't shatter excessively, not like many types of hard rock might.
Right, so the thinking was you could build tunnels or underground rooms in permafrost.
And they'd be relatively stable. The roofs could hold up well under explosive loads.
And it'd be easier or faster to dig out than solid bedrock?
That was part of the idea, potentially. Plus, there's a thermal advantage.
Right, the temperature inside.
Exactly. Inside a permafrost tunnel, the temperature stays pretty consistent, just below freezing. Now, that sounds cold to us.
But compared to outside in Arctic winter...
Exactly. It's significantly warmer than the brutal outside air. So they could function as, like, effective, naturally heated shelters.
Interesting. So there was this kind of strategic angle early on, but the scientific possibilities, which our sources really highlight, those seem even more compelling.
Oh, definitely. Permafrost is essentially this one-of-a-kind scientific laboratory.
Yeah.
And the KRL Fax Permafrost Tunnel project up in Fairbanks, Alaska, that's just a prime example of this.
CRREL, that's the Army Corps of Engineers lab, right? Cold Regions Research.
Cold Regions Research and Engineering Laboratory. That's them. They're the experts in dealing with cold environments. And yeah, they do extensive permafrost research. This particular tunnel, the Fox Tunnel, It actually serves multiple purposes.
One thing mentioned, which I found fascinating, was using it as an analog for Mars.
Yeah, because scientists think there's subsurface ice on Mars, right?
Yeah.
So studying how ice behaves within soil here on Earth in this controlled-ish environment.
Can give us clues about what we might find on other planets.
Precisely. But just focusing back on Earth, the permafrost itself, it's like this treasure chest of ancient information.
Because the ice preserves things so well.
Incredibly well. Organic material, even ancient life. Researchers in the Fox Tunnel, they've studied everything from like bacteria and old plant tissue to actual animal bones preserved for thousands and thousands of years.
Wow, like what kind of bones?
Well, one source mentions steppe bison bones. They used isotopes from those bones, dating back maybe 18,000 to 43,000 years, to figure out the migration habits of these animals that are long extinct now.
So you can literally walk into this tunnel and see right there in the wall, frozen, the remnants of ecosystems and life from tens of thousands of years ago.
That's exactly it. It's this tangible link to deep time right there.
It really just underscores the incredible complexity, the richness that permafrost holds, and how much we're still figuring out, about Earth's history, past climates, ancient biology, all from these frozen archives.
It's a remarkable window into the past, but as we're finding out very quickly, permafrost is also becoming this crucial indicator for the planet's future.
And that brings us right to why permafrost is now, well, quite literally a burning issue. Why it's generating so much global alarm.
Climate change.
It's directly tied to climate change, yeah.
Historically, permafrost has been one of Earth's biggest carbon sinks. You can think of it like a giant freezer, right? Storing all this organic material, plants, animals, microbes that died but never fully decomposed because it was frozen solid.
So it's kept colossal amounts of carbon locked away for millennia.
Exactly. But the major, really alarming shift that the sources document is that as global temperatures rise, the permafrost is thawing. And that stored carbon is not locked away anymore.
It's being released.
It's being released. And the scale of this potential release is just immense.
How immense are we talking?
Well, one analysis highlighted in the sources suggests that thawing permafrost is already releasing somewhere between 300 and 600 million metric tons of planet-warming carbon into the atmosphere every single year.
300 to 600 million tons a year? That's hard to grasp.
To put it in perspective, that's comparable to the total annual industrial and transport emissions of, say, France or Canada.
Wow.
It's this feedback loop that scientists are watching with extreme concern. More warming thaws, more permafrost, which releases more carbon, which causes more warming.
Right, it just feeds itself. And it's not only carbon, is it? There's this other concern, which sounds almost like science fiction.
The dormant microbes.
Yeah, microbes locked in the ice for potentially thousands of years. Could they be pathogens, things we have no immunity to?
That's the worry. And it's not just, theoretical anymore. One source brings up the 2016 anthrax outbreak on the Yamal Peninsula in Siberia.
Anthrax. I remember hearing about that.
It was the first outbreak there in 75 years. And the investigation pointed directly to a heat wave thawing the permafrost.
Oh, wow.
It exposed the carcass of a reindeer that had died from anthrax decades ago. Spores got out, infected grazing reindeer, which then passed it to humans.
That's terrifying. Did people...
Tragically, yes. A 12-year-old boy died, and at least 20 other people were hospitalized.
Good grief. That story is chilling. It really underscores the immediate risks, doesn't it? Adds another layer of urgency to the research happening in places like that Alaska tunnel.
Absolutely. So let's go back to that tunnel, the Fox Permafrost Tunnel in Fairbanks, Alaska. It's a CRL project, remember, U.S. Army Corps of Engineers.
Right.
And it's deliberately located in this abandoned gold dredging field. The tunnel itself is driven straight into a steep cliff that's made of this perennially frozen silt right at the edge of the field.
Why that specific spot?
Because the permafrost there is particularly rich in ice and organic material. So it's ideal for studying the properties of that kind of ice-rich frozen ground.
Okay, and what's it like approaching the entrance?
Well, the descriptions say it almost blends in. It's like a semicircle opening covered with birch and spruce trees. Pretty unassuming from the outside.
But inside is different.
Oh, yeah. You step inside, and there's this metal boardwalk raised up a bit from the floor. And the floor itself is covered in this really fine, almost cocoa-colored dust. Fluorescent lights hang down, lighting the way, and you see electrical wires running along the walls.
And the walls themselves, that's where you see the permafrost up close.
That's where you really see it. It's this frozen mix, mostly silt, but embedded all through it are roots, bits of plants, even larger chunks of organic stuff, it looks like. like a masonry of ice and silt, just preserving these fragments of ancient ecosystems.
And that's the stuff containing those old bacteria and the never-rotted tissue we were talking about.
Exactly. And that preservation, that kind of suspended state of decomposition over thousands of years, that's what create that really unique smell.
The cheesy, earthy, sweaty socks, manure smell.
That's the one. It's the smell of biology, basically put on pause for millennia.
Geologically, what's the silt like there?
It's mostly fine-grained material. The sources mention specific minerals, like mica's biotite, muscovite, and clay-sized particles, too. They note the particles look angular and unweathered.
Meaning they weren't tumbled around much?
Probably not. Suggests they were likely deposited as wind-blown sediment, what geologists call loess.
And you can actually see different kinds of ice in there, too, right? Not just one solid block.
Definitely. The sources mention seeing different types, segregated ice, pore ice filling the gaps, and these really impressive, massive ice wedges. It shows the complex ways water freezes and moves within the soil over long periods.
Now, the permafrost at this specific site, the Fox Tunnel site, it has some interesting local characteristics, doesn't it? It's considered warm permafrost.
Relatively speaking, yes. The minimum temperatures only get down to around -2 degrees Celsius, and it's also discontinuous.
Meaning it's patchy, not frozen solid everywhere.
Exactly. There are areas of unfrozen ground called talix mixed within the perennially frozen zones in that Fairbanks area.
Which is a bit weird, apparently, based on the climate.
It is a bit puzzling. The ratio of freezing degree days to thawing degree days. They're basically how much cold versus warmth you get cumulatively over a year is about 1.7 to 1.
Okay.
Normally, you'd expect a ratio like that to support continuous permafrost and probably colder average temperatures, closer to the overall yearly average.
So why is it warmer and patchy there?
Well, one idea mentioned in the sources is maybe increased geothermal flux, more heat coming up from deep within the earth than usual in that specific spot.
But they don't know for sure.
It seems not. The report says the geothermal gradient hasn't been studied accurately enough there to definitively say that's the reason, so it remains a bit of a local scientific mystery. The area is also pretty dry, only about 30 centimeters of precipitation a year.
Though they get a lot of snow.
Yeah, up to 100 centimeters of snow cover in winter, which does act as an insulator.
And the tunnel itself isn't static, right? They've expanded it.
They have. For ongoing research, there's a newer section dug out between 2011 and 2018. And that's where they exposed these absolutely massive ice wedges. Some were up to 15 feet wide.
15 feet of solid ice wedge. Wow.
Yeah, and one source even notes that some of the academic scientists studying these wedges actually got hands-on with heavy machinery, digging out parts of this new section themselves.
Shows dedication.
It really does. So, yeah, the tunnel is this incredible window into permafrost, its makeup, its history, its temperature dynamics, the ancient life it holds.
But getting into that environment, and maybe more importantly, trying to build within it, that presents a whole different set of challenges. Very different from working with normal rock or soil.
Oh, completely different.
Yeah.
And those difficulties, the challenges of construction in permafrost, that's actually what helped kickstart a lot of the early cold regions research.
You mean like way back?
Yeah, the sources mention the Alaska highway construction during World War II back in 1942. The Army Corps of Engineers built the road right on top of the permafrost. Well, predictable result, really. The disturbance, the warmer road surface, it thawed the ice-rich ground underneath.
Oh dear, mud.
Catastrophic mud. The ground basically turned into this deep slurry that just swallowed heavy equipment. Trucks got stuck. It was a mess.
What a nightmare.
But it was a hard lesson learned. It really highlighted the critical need to understand how permafrost behaves, and that led directly to establishing research centers like CRLL.
Okay, so fast forward a few decades, CRL is still trying to figure out the best ways to actually dig into this stuff. One of the technical reports we looked at goes into detail about an experimental tunneling project. They used a specific machine called the Alkirk Continuous Miner.
Alkirk.
Yeah, it was apparently a prototype, like a first-generation machine, originally designed for coal and soft rock, but they were testing it to see if it could work in this warm permafrost.
How did it work? Was it like a normal tunnel boring machine?
Not quite. It had this really unique way of moving forward. They called it the twin pilot pull principle.
Pilot pull.
Yeah, instead of pushing off the walls, it drilled two small anchor holes ahead of the main cutting face. Then it fastened itself into those holes using these things called packers.
Okay.
And then the whole machine would literally pull itself forward against those anchors.
Huh. That is different. Any advantages to that?
Potentially, yeah. It meant the machine could be relatively lightweight, didn't need heavy counterweights or powerful jacks pushing against the tunnel walls. The main cutting came from two big arms, about 7 feet in diameter, rotating opposite ways in overlapping circles.
Got it. But this is where the permafrost challenges really kick in, right?
Exactly. Because the material itself, the frozen silt, the ice, the bits of organic stuff, it behaves so differently from rock. It's hard when frozen, sure, but it's also full of ice and really sensitive to heat.
Heat is the enemy.
Totally. The Alkirk machine, on paper, had a potential digging rate of several meters per hour, but actually achieving that meant overcoming huge hurdles specific to the permafrost environment. The report is pretty frank about the problems they ran into.
Like what? What went wrong?
Well, take the hydraulic system, for example. It was complex, typical prototype stuff, but it was super prone to failure in the cold.
Ah, the cold itself was an issue.
Big time. They
Yeah.
documented frequent problems. Airlocks in the lines, broken hoses and fittings, pump failures, motor failures, constant fluid leaks. The report even noted high pressure surges happening, maybe because the system was struggling against the weird resistance of the frozen ground.
How much downtime did that cause?
The report tallied over 100 hours of lost time just due to hydraulic system problems. So it wasn't just like a mechanical breakdown here and there. It showed that standard hydraulics really struggle in that cold, unforgiving environment.
And you mentioned heat being a problem.
Yeah, that compounded things. The hydraulic fluid would overheat. That heat transferred to other parts of the machine, including those crucial anchors, the pilots and the packers that gripped the anchor holes.
So if the packers got warm,
They'd start to melt the ice around them just slightly, lose their grip, and slip. The machine couldn't pull itself forward. Packer failures alone caused another big chunk of lost time, 38 hours documented in the log.
wow. So heat management is absolutely critical. Heat equals thaw, thaw equals instability, and instability equals failure.
Precisely. Even the tracks on the machine, designed for maybe softer mine floors, they couldn't handle the frozen permafrost floor. They had to lay down plywood just to move the thing around.
Plywood.
Seriously. And the tracks got damaged easily by little pebbles frozen into the ground. The cutting speed was low, the tools weren't quite right for that weird mix of ice and frozen soil.
Which meant they had to push it harder.
Yeah, they called it excessive crowding. Pushing the machine harder than designed, which has put more stress on that already iffy anchoring system and led to more failures. It was kind of a vicious cycle.
And it wasn't just the miner itself, right? Didn't the support equipment cause problems too?
Oh, yeah. The standard mining gear they tried to use wasn't always compatible. Like the shuttle car they used to haul away the excavated muck, the spoil,
What about it?
it didn't actually fit properly under the miner's conveyor belt. They had to use a front-end loader as an intermediary just to transfer the material from the miner to the shuttle car. Added complexity, added time.
That sounds incredibly inefficient.
It was. And even with that workaround, the shuttle car just couldn't keep up. Its capacity was way less than what the miner could potentially dig out. So the miner would dig a bit, then have to wait while the shuttle car was loaded, driven out, emptied, and driven back. Major bottleneck.
The data probably shows that pretty clearly.
Yeah, the report's haulage data confirms it. Loading and unloading only took a few minutes each, but the overall ratio of actual time spent mining versus total operation time was really low because of all these combined issues.
And the repairs must have been constant.
The appendix detailing the maintenance and repair time is pretty eye-opening. A total of 364 hours spent just on repairs, requiring 910 man-hours of labor.
Good grief. What kept breaking?
All sorts of things. The upper cusp cutter that was apart needed to shape the roof properly that failed for 82 hours total. Lots of general mechanical failures, problems with the elevating conveyor that moved the spoil, and those persistent operational failures like the packers slipping.
So it was the machine itself constantly fighting the environment.
Absolutely. And even the support gear had problems specifically because of the cold. The shuttle car's electrical cable insulation became brittle from the frost and tore. The front loader had frozen hydraulic lines, frozen conveyor parts, broken bearings. Even the stationary equipment like the refrigerator unit for cooling air and the power systems had issues.
It sounds like a constant battle just to keep things running. What about the people operating it?
Well, the experimental crew was pretty large engineers, technical staff, project leader, but the report actually found that just throwing more people at the problem didn't speed up the excavation at the tunnel face. Because conditions were too crowded in the tunnel, and the real bottlenecks were the equipment failures and the slow spoil removal. It wasn't a lack of manpower, it was an engineering challenge specific to working in permafrost.
Makes sense.
They also noted it took significant training just to operate the miner, like 3 months for an operator to get proficient. And the labor utilization data showed a huge amount of time spent on repairs and maintenance. The report basically concluded that productivity could probably be tripled just by cutting down that repair time.
Tripled. That's massive.
Yeah, it really highlights how much the permafrost itself was impacting the operation. Oh, and ventilation was another special consideration.
Different from normal tunnels.
Yeah, because its main job wasn't just fresh air or dust removal. The primary purpose of ventilation and permafrost tunneling, according to the report, is removing all the waste heat generated by the machinery.
Ah, back to the heat problem again.
Exactly. You need to get that heat out to prevent thawing at the face. And the ventilation system they had during the experiment actually wasn't powerful enough for the amount of heat the Alkirk miner was putting out, especially when it was working hard.
So they needed way more airflow.
Considerably more. The report gave estimates based on cutting rate and outside temperature needing hundreds, maybe up to 900 cubic meters per minute of airflow just to manage the heat.
Wow. And the tunnel itself needed support, right? It wasn't just digging a hole.
No, they had a portal structure made of steel culvert and wood, an insulated bulkhead. Inside, the layout diagrams show lights, the ventilation duct running along, telephone lines, power cables for the miner and controls, compressed air lines, even arch roof supports made of steel ribs and timber lagging in some sections to help maintain stability.
So this whole story of the Alkirk miner, while super technical, it really gives us a crucial insight, doesn't it?
Yeah, I think so.
It shows that conventional engineering, equipment designed for regular rock or just unfrozen ground, it really struggles when it meets the unique properties of permafrost, this ice-cemented soil.
You have to rethink everything.
Totally. You need to focus on heat management above all else, probably need specialized tools, more robust systems designed specifically for this dynamic frozen material. It just reveals how much complexity is hidden right there beneath the surface.
And that complexity, that dynamic nature, it extends beyond just trying to build in it, right? The permafrost itself isn't static, even when it's frozen.
No, definitely not. It's part of the Earth system. It moves, it changes temperature, and as we're seeing more and more, it becomes unstable as it warms.
How does it move? Like a creep?
Yeah, deformation over time. Unlike brittle rock that might just fracture suddenly, rock bursts are basically unthinkable in permafrost. The ice within it is relatively weak. Under sustained load, it's subject to greater plastic deformation. It can slowly change shape.
Does the soil mixed in affect that?
It does. Interestingly, the sources note that clean ice actually deforms slower than mixtures of frozen rock debris and finer rain to permafrost, especially if it's supersaturated with ice and near the thawing point. That's particularly prone to deforming plastically. It seems like the soil particles actually weaken the ice structure somehow.
And they've actually seen this deformation in the Alaska Tunnel.
They have. Observations showed noticeable deformation of the walls and ceiling over time, even though there isn't a huge amount of rock or soil pressing down from above.
Why would it deform then?
The tentative explanation is temperature differences within the tunnel itself. Like the areas near the entrance portal or near the active work phase, they tend to be a bit warmer than the middle sections, maybe even a 10 degrees Celsius difference. These temperature gradients can drive differential thaw and slow deformation.
Huh. And air moves around inside too.
Yeah, especially in tunnels that are nearly horizontal like the Fox Tunnel. There are these natural air currents that actually reverse with the seasons.
Reverse?
In winter, the cold, dense outside air flows in along the floor of the tunnel. This pushes the slightly warmer tunnel air up and out towards the portal along the roof. They measured air speeds up to 2.5 kilometers per hour from this effect.
So keeping the door shut helps keep it cold.
Exactly. The report mentioned that simply keeping the portal tightly closed and reducing activity inside helped the tunnel accumulate some heat sink capacity, basically stay colder.
But the really dramatic signs of instability, those come from water and actual thawing, right?
Oh, absolutely. The sources describe several flooding events that have directly threatened the tunnel's integrity over the years.
Like actual floods inside the permafrost tunnel.
Yeah. Back in 1993, floodwater somehow collected at the back end, and it caused the ceiling to warp, and apparently significant amounts of silt fell down. Then, in 2014, meltwater from a nearby hill slope seeped in, leaving these frozen puddles inside.
Okay, that sounds bad, but maybe manageable.
Well, then came 2016. They described it as they nearly lost the tunnel.
Whoa, what happened?
Heavy rains changed the surface drainage patterns above the tunnel. Water found a path down and infiltrated a massive ice wedge located right next to the tunnel entrance.
Oh, no.
The force of the water, plus the erosion as it melted the ice wedge from within, it carved out what was described as a house-sized piece of the permafrost wall before they could get the water pumped out.
A house-sized chunk just eroded away.
Yeah, they managed to stop it, pump out most of the water, but the sources say patches of flood ice from these events still linger in the tunnel today. It contributes to this pervasive feeling, this sense that the underground is not stable.
That feeling that the solid ground you're standing on isn't quite so solid anymore?
Exactly. The frozen ground feels hard, but in places it's clearly showing signs of yielding, of instability.
And this localized instability they're seeing in the tunnel, it's basically a small-scale version of a much bigger, much more alarming trend happening outside, right?
Precisely. The rising average temperatures in places like Fairbanks. I mean, the mean annual temperature actually went above freezing there in 2019.
Above freezing for the whole year's average.
Yeah. And for permafrost that exists so close to 0 degrees Celsius anyway, like the warm permafrost there, it just cannot survive many more years like that. The frozen ground itself, across huge regions, is becoming fundamentally unstable.
And that instability, it's not just, an engineering problem for tunnels or a scientific curiosity. It has these profound, tangible, often devastating impacts on the people who actually live in these regions.
Especially Northern Indigenous communities. The Canadian Climate Institute report we looked at laid this out with really stark clarity.
Yeah, that report was powerful. It makes it clear that permafrost thaw isn't happening in isolation, right? It's a direct result of climate change, but its effects are hitting communities alongside other climate impacts and also on top of the legacy of historical changes.
Like forced relocations, changes to traditional ways of life imposed from outside.
Right. It's all combining to transform lives and landscapes in these really complex ways. There was that quote from a participant in the report about their ancestors understanding the land so well.
The one about mobility.
Yeah, saying that their ancestors worried that if you stayed in one spot too long, you were actually killing the island of Igloolik. That deep understanding of the land, the connection, it just highlights how significant these changes are.
And the impacts on traditional lifeways, hunting, trapping, fishing, they're immediate and severe. Permafrost thaw messes with habitats directly.
How so?
Well, riverbanks slump and erode because the frozen soil holding them together thaws. That dumps sediment into the water, which can harm fish populations. Changes in vegetation, like loss of lichen that caribou depend on, impacts their habitat. Makes it harder to find them, harder to hunt them.
And just getting around becomes harder, too.
Incredibly difficult and risky. As the ground thaws, it can turn into this slumping, boggy, unstable mess. Travel routes on land, routes people have used for generations, they become unsafe, sometimes just impassable.
So longer trips, more dangerous trips.
Yeah, it increases travel times hugely, makes trips more dangerous, and can even force people to abandon traditional hunting or fishing or trapping areas that their families have relied on for, well, forever.
Is there an example of that?
The report mentions one from the Mackenzie Delta. Ground slumping caused by thaw made a specific channel, Anderton Channel, basically unnavigable by boat.
So people just couldn't use it anymore.
Right. They now have to take this hour-long detour, and that detour costs them an extra 12 or more liters of fuel every single trip.
12 liters extra per trip, just for subsistence hunting or fishing. That adds up incredibly fast.
It's a huge burden, added cost, added time. And the direct result often is fewer successful harvests of country foods, traditional foods in the land.
Or it just takes way more effort, more time, more money to get the same amount.
Exactly. One participant in the study just lamented that people don't hunt as much anymore. They're forced to rely more on expensive store-bought food, which they said was not very healthy. Just harder to find game in the old familiar places.
But communities are adapting, right? Finding ways to cope.
Oh, absolutely. The resilience is incredible. They're doing things like organizing community hunts, pooling resources to travel much longer distances to where game might still be found. They're using freezers to store harvests, sharing food widely, especially with elders and families who can't get out themselves.
But that adaptation itself comes at a cost.
A significant cost, yeah. Investing in new, different equipment, maybe more powerful four-stroke snow machines that are more reliable or fuel efficient. Larger boats, maybe with long-tail motors for shallow, tricky waters. Generators to run those freezers out at remote cabins. Satellite communication devices like in-reaches for safety because the land is becoming so unpredictable.
All of that costs serious money.
Serious money. It's an additional financial outlay just to maintain traditional practices in this changing environment.
And the impacts, they go beyond subsistence, right? To infrastructure, travel.
Definitely. Critical infrastructure that connects communities' roads, airstrips, they're getting damaged by the slumping and thawing ground too.
And those aren't just conveniences.
Not at all. They are vital lifelines for bringing in store-bought goods, especially food, for accessing education, medical services, for maintaining family connections between scattered communities. When roads or airstrips are damaged or closed, the consequences are severe.
And fixing them must be incredibly expensive.
Immense costs. The report gave this really stark example from the Iqaluit Airport in Nunavut between just 2014 and 2017. So a 3-year period, they needed $300 million for repairs.
$300 million.
Just for repairs to the landing strips and facilities,
Right.
just to keep the airport functional because of ongoing permafrost damage beneath it.
Wow. And even new roads aren't immune.
Seems not.
Yeah.
The report mentions the Tlikio All-Season Road in the Northwest Territories. It was actually built partly as an adaptation, right, to provide a more reliable link as the winter ice roads become less dependable due to warming. But even this brand new road, built with modern techniques, is itself exposed to potential damage from permafrost thaw along its route. Building anything, maintaining anything in the north is already super expensive, and thaw just adds this massive, unpredictable layer of cost and risk.
And this vulnerability of infrastructure, it loops back to food security, doesn't it?
Directly. Both traditional food systems and the store-bought system are hit hard.
How are traditional food systems affected beyond the hunting difficulties?
Storage. Traditional ways of storing country food, like digging pits into the permafrost natural freezers or underground cellars, they're literally thawing out.
Back to this food spoil.
Or the cellars just become unusable. Participants describe their family ice cellars filling up with water as the ground thaws around them, forcing them to abandon methods used for generations.
Which means shifting to
Chest freezers, often run by generators, maybe out at remote cabins. Which means, again, the added cost and labor of constantly hauling fuel, sometimes long distances, just to keep their traditional foods frozen. Another burden.
And the store-bought food system, the grocery stores, they're vulnerable too.
In multiple ways.
Huh.
The buildings themselves can literally sink or become unstable as the ground shifts beneath them. One participant talked about their local store sinking. Another mentioned a caribou processing plant having to shut down because the building became unstable.
Okay, structural issues. What else?
Power outages. If power lines are damaged by slumping ground, which happens, you risk widespread food spoilage in the store's freezers and coolers. And, as we said, the stores rely heavily on air transport for resupply. If the runway is closed for repairs because of thaw damage, the shelves can get empty fast.
And food in the north is already so expensive.
Exactly. So this increased dependency, coupled with the risk of supply disruptions, just exacerbates the already high cost of store-bought food. Participants highlighted those huge price differences, like a chicken might be $9 or $10 down south, but $35 or more in their community.
So hunters face this awful calculation.
Yeah, this really difficult, stressful choice. Do I risk going out on the land, which is increasingly dangerous and expensive? Or do I buy food from the store that's prohibitively expensive and might not even be reliably available or safe from spoilage?
And there's another risk too, right? Contaminants.
Yeah, that's a really worrying aspect. As permafrost thaws, it can release things like mercury and other contaminants that have been locked away in the frozen soil, sometimes for millennia from natural or industrial sources.
Where do they go?
They can leach into water sources, rivers, lakes. Then they get into the food chain, potentially making harvested country foods unsafe to eat. There's a risk of disease transmission that way, too.
And infrastructure failures can release contaminants too.
Definitely. Things like oil and gas pipelines, or even local fuel tanks and sewer lines buried in the ground, they're highly vulnerable to breaking if the ground shifts due to thaw.
And a break means
Spills, chemical releases, environmental contamination. One participant shared a story about a home fuel tank line breaking because the ground shifted. The cleanup cost $40,000 to $80,000. Some homeowners had to remortgage their houses to pay for it.
$40,000 to $80,000 for a home fuel spill. That's devastating.
It really is. And it highlights how these seemingly small infrastructure vulnerabilities can have huge financial and environmental consequences.
It sounds like housing in general is taking a big hit.
Widespread damage. homes, community buildings.
Yeah.
They're built on foundations that are now literally moving as the permafrost thaws underneath.
What does that look like?
Cracks in walls, cracks in drywall, windows that won't open or close properly, doors that stick. More serious structural issues over time.
And fixing it is expensive.
Astronomically expensive, both for individual households and for entire communities. The cost of repair, just ongoing maintenance, even getting insurance if you can get it for thaw damage, it all adds up. It can lead to substandard housing, worsen the existing housing shortages common in the north.
And even basic utilities are affected.
Yeah, leaks in connections become common. Things like utilidors, those enclosed corridors that carry water and sewer pipes in some northern communities, or just regular pipes and fuel tanks connected to houses. They can shift and break. That fuel tank issue, needing longer, flexible connection lines just to accommodate expected ground movement. That tells you how dynamic the situation is.
And fixing the house itself. It's often not a permanent solution, is it?
Rarely. As one participant put it, you might spend thousands of dollars to re-level your house this year, but the ground keeps thawing and shifting. You might have to do it again next year and the year after. It doesn't solve the fundamental problem.
Who pays for that?
Sometimes housing authorities might cover some costs, but often homeowners are left holding the bag. Insurance frequently doesn't cover damage from gradual thaw or ground settlement.
And the report made a point about looking beyond just the cost of fixing one building, right?
Yeah, it emphasized that we need to think about the role these structures play in the community's overall well-being. Like, damage to a community food warehouse isn't just a building repair cost. It impacts food security for everyone. The ripple effects are huge.
Maybe the most profound impact, though, the one that's hardest to quantify, is on culture, on knowledge.
I think you're right. The increased difficulty and risk of just traveling on the land, it directly leads to people spending less time out on the land.
And that time is crucial.
Absolutely essential is how traditional skills and knowledge get passed down, from elders to younger generations. Vital knowledge about hunting, trapping, fishing, how to navigate, how to read the land, the water, the weather, intimately.
So if people are out there less,
That irreplaceable knowledge transfer gets disrupted, hindered, lost, potentially.
and the land itself is changing visually, too.
Yeah, the physical landscape changes, vegetation shifts, drainage patterns alter, familiar landmarks might disappear or change due to thaw and erosion. Indigenous cultures have always adapted to environmental change. That's key. But the speed of the changes happening now is unprecedented. It can create this feeling of dislocation, like the land itself is becoming unfamiliar.
That must be deeply unsettling.
There's a real worry expressed by participants, especially elders, about the future for the younger generations.
Yeah.
They need a Western education to navigate the modern world, that's understood. But there's this deep concern that they might lose their fundamental connection to the land, to the traditional ways.
Losing that anchor.
Yeah. One participant voiced this worry about grandchildren maybe becoming self-centered, about that deep, nuanced understanding of the land just disappearing as the elders pass on.
But resilience is still strong. Adaptation is happening.
Absolutely.
Yeah.
Resilience and adaptation are just fundamental. As one participant said so powerfully, their ancestors knew it was adapt or die.
Yeah.
Elders often say they aren't surprised by change itself, just by the incredible speed and scale of the current changes.
And sharing knowledge is part of adapting.
A key part. Even using modern tools. People share observations about changing ice conditions, unsafe ground, good hunting spots through community gossip networks, but also increasingly through things like local Facebook groups. Sharing information is a critical adaptive mechanism in this rapidly transforming world.
Okay, so we've gone from the microscopic makeup of permafrost.
Yeah, down to the smell.
To the smell, yeah. Explored the really unique engineering challenges of trying to build in it, seen the physical signs of it becoming unstable in that specific tunnel.
And then connected that to these huge, far-reaching, deeply personal impacts on the communities who live on and rely on these landscapes.
Let's just circle back briefly to the Fox Tunnel itself. It's still there, still a critical research site, right?
Oh, yeah. And it feels, in a way, like it's become a symbol of this whole changing world. They're actively working to extend its research life.
How?
Experimenting with things like using solar panels to power chillers, trying to keep it frozen longer. And there was a recent project to actually double its size, to study different permafrost properties, develop new ways to scan and understand it, like using radar alongside just looking at it.
So the work continues, trying to understand it even as it disappears elsewhere.
But there's this sense, as one source described it, that the tunnel is becoming almost like a captive rare animal, preserving this form of Earth that might soon be largely lost, at least near the surface, on a massive scale.
And the work there becomes a way to kind of reckon with that loss.
I think so. Reckon with the loss and understand its cascading effects across the Arctic and subarctic. The research chemist there, Thomas Douglas, he even joked, apparently, about the possibility that someday they might have the only permafrost in the Fairbanks area as the ground all around it continues to thaw.
That's a sobering thought.
It really is. Because the scale of the predicted change, it's just immense. The projections mentioned in one source suggest that most of Alaska's near-surface permafrost,
Yeah.
it's likely to fall apart, to thaw irreversibly within the next 80 years.
80 years.
You're gonna-
That's within a single human lifetime.
Exactly.
And the consequences of that much thaw.
They'll fundamentally alter the landscape. It'll change hydrology, how water flows, where lakes form or drain, where rivers run. It will transform vegetation patterns completely, snowpack dynamics, the timing of the spring melt, the heat exchange between the ground and the atmosphere, animal habitats. Everything changes.
So Alaska, the entire far north, millions of square kilometers, will become, as the source put it, a fundamentally different place.
A fundamentally different place.
So why does this matter? Why have we spent all this time doing this deep dive into frozen ground, tunneling problems, the experiences of communities that might feel very distant to a lot of our listeners? Why should you, listening now, care about this?
Because permafrost thaw isn't just some localized remote phenomena.
Yeah.
It's one of the clearest, most significant, most visible signals of global climate change that we have.
Right.
And the tangible human consequences that are happening now in the North, they offer a kind of preview, a warning maybe, of the kinds of challenges, environmental, infrastructural, social, cultural, that many other parts of the world might eventually face as the climate continues to shift.
It really shows how interconnected everything is, doesn't it? Our planet's systems. And it highlights the surprising vulnerability of the stuff we've built, the ways of life we assume are stable, to rapid environmental change.
And the adaptations, the resilience, but also the struggles of northern communities living with this thaw right now. They offer really crucial lessons for everyone, everywhere.
So we've journeyed deep underground, haven't we? Grappled with the surprising difficulty of building in this frozen, dynamic environment. We've seen the physical signs of thaw making things unstable.
And perhaps most importantly, we've tried to understand the profound, multi-layered impacts this is having on the people, the cultures, and the landscapes of the North.
Permafrost. It's so much more than just frozen dirt, isn't it?
Oh, yeah. It's this complex, dynamic part of the Earth system. It holds secrets from the deep past, and it's posing these huge, urgent challenges for our collective future.
Building in it is tricky business, we learned that. And its rapid thaw is creating these immense, costly, culturally disruptive problems for the people who live with it every single day.
So, as we think about that future, a future where huge areas of the planet could become fundamentally different places within our own lifetimes, what does the impermanence of permafrost, something that seems so permanent, tell us?
What does it tell us about the stability of the world we've built? Both the literal things, the structures, the infrastructure.
And the figurative things, the systems, the assumptions that kind of underpin our modern ways of life. What questions does exploring all of this leave you asking?